Before we try some practice problems with prime and composite numbers, let's review some vocabulary. A factor is all of the numbers that we can multiply together to get another number. So for example, 2 and 3 are both factors of 6 because 2 times 3 is 6. A prime number are numbers that only have two factors, 1 and itself. I like to remember prime by thinking of the word Prime. So inside of the word prime, you see the word me. This I looks a little bit like the number 1. So prime is 1 and me. They are numbers that only have one factors, 1 and itself. So prime, 1, and me. Composite numbers are numbers that have more than two factors. For example, 18 is composite because 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is also 18. I remember composite because composite is a longer word and there are much more numbers that are composite than there are numbers that are prime. A factor pair is a set of two numbers that when multiplied together result in a specific number. So for example, the factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Those are all of the pairs of numbers that when multiplied together would equal 24. We call those factor pairs. There's several ways that we can determine if a number is prime or composite. First, we have to think about those divisibility rules that we've learned about earlier this week. You can think about those arrays that you can build. If you can only build one array, then of course it's a prime number. If you could build more than one array, then it is a composite number. But sometimes it just helps us to think about the factors and write them down and realize that if there are more than two factors, then it's composite. If there are only two factors, then it's prime. So one way we can do that is just by making a simple list. So for example, 48, if we listed all of the factors of 48, we would list 1, 2, 4, 6, 8, 12, 24, and 48. If I listed the factors of 39, I would start with 1 and 39, of course. But I also know that 39 is divisible by 3. That means if I divided 39 by 3, it would go equally. So 3 goes into 3 one time. And then 3 also goes into 9 3 times. So 13 and 3 are also factors of 39. 39 is not an even number, so it can't be divided by 2. It doesn't end in a 5 or a 0, so it can't be divided by 5. If I were to list all my factors or multiples of 7, 14, 21, 28, 35, 42. Okay, so 39 is not in that list there. I just skipped right past it. So 7 is not a factor of 39. 39 could not be divided by 11 equally because 11, 22, 33, 44. So 39 gets skipped right past. So I believe the only factors of 39 are 1 and 39 and 3 and 13. So a list can help us determine. So because both 48 and 39 have more than two factors, both of those numbers are composite. A factor tree is also a way of showing a number's factors to help you to determine if it is prime or composite. So I start out with my number up at the top and then I start making some branches. 1 times 48 equals 48. 2 times 24 equals 48. 24 can be divided by 2 evenly, so 2 times 12 is 24. I could keep going, but automatically, because I have more than just those two branches, this is a composite number because I have 1, 2, 3, and I could keep going. So I know off the top of my head that that is composite just by making this factor tree. If I were to make my factor tree of 39, I would have 1 and 39, and then we already decided that 39 was divisible by 3, so 3 times 13. I couldn't keep going because both 3 and 13 are prime numbers, but because I have a second branch, then I know that 39 is a composite number. We can also make some factor rainbows, so this is exactly like what you think. It looks like a rainbow. So I start out by doing 48 and 1, and then I connect them. And then I can keep going. I can do 2 times 24 to make 48, and I connect them. I can do 3 times 16 to get 48. I can do 4 times 12 to get 48. And I can also do 6 times 8 to get 48. So because I have more than just one little rainbow, I know that this is composite. 39, I would have 1 and 39, and 3 and 13. Because I have more than just that one connection, this is a composite number. We can also put our factors into a T-chart to show a list of the factor pairs to help you determine if it is prime or composite. So I would start again with 1, 48, 2, 24, 3, 16. Because I already have more than 2 factors, I know that 48 is composite. If I was going to do the same thing with 39, I would have 1, 39, 3, and 13. There are more than 2 factors, so 39 is composite. So when it comes to prime and composite numbers, here's what we have to remember. The number 1 is neither prime nor composite because it is not greater than 1. And it doesn't have more than 1 factor. The only factors of 1 are 1 in itself. So 1 times 1. It doesn't have 2 different factors. 2 is prime, even though it's an even number. It is the only even prime number, though. All other even numbers are divisible by 2, so therefore they are composite numbers. And remember, just because a number is odd does not mean it's a prime number. 39 is a really great example of that. It has more than 2 factors and it's odd, so we consider 39 a composite number.